All right, so what do we have here? Question 13. We have to prove the algebraic identity. All right, just a good example of proof. Make sure you do one side at a time. So for example, the left-hand side here is 1 minus t squared all squared, so square the first term, double the product, square the last term, and the square of 2 is 4 and the square of t is t squared. When we simplify that, we get 1. We've got 2t squared because a negative and a positive 4 here, and we've got a t to the power of 4. All right, our right-hand side, on the other hand, is 1 plus t squared all squared. So again, square the first term, double the product, square the last term, and you get the exact same answer. So now you can either say, here, therefore, left-hand side equals right-hand side. So therefore, we've proven that 1 minus t squared squared plus 2t squared equals 1 plus t squared squared. You know what I mean. Alright, so what I'm going to do though is get rid of all that. So we've proved the identity. So once you've proved the identity, you can just use the identity, which will come in handy here. So now we know, if I draw my right angle triangle, we're told that the angle x is an acute angle. So therefore we know it's in the all stations to central. It's in that first quadrant where sine, cos and tan are all positive. If we know then that cos of x can't always hide, so always is here, so adjacent, can't always hide, and here we go. So if I put those from here, I've got can't always hide, adjacent over hypotenuse. If I put that fraction, you can break it up however you like. If it's already a beautiful fraction with numerator and denominator, usually we just use those two. Using Pythagoras, if you think about it, what I'm doing is I'm taking the hypotenuse squared, and that comes from here, and I'm minusing 1 minus, not again, 1 minus t squared. So get rid of that. Sorry about this. Alright, so we're minusing 1 minus t all squared, which is this part here. So we're taking that over there. And so clearly we will get this side as 2t. So it's kind of done, the proof the algebraic identity, the part A is to help you find the other side of the right angle triangle. Alright, so once we know that, again, as we usually do, we've got sine x, some old x, are opposite over hypotenuse, and we've got tan x, they're old, opposite over adjacent. And I'll just add cos there, cos x, which we were given is the weird one, or in a way it's the weird one. And these are really important identities that we are going to use. Sine x equals 2t on 1 plus t squared, cos x is 1 minus t squared on 1 plus t squared, and tan x equals 2t on 1 minus t squared. Alright,